This is a terrestrial rover that I'm currently developing. It is designed to explore the ecosystem and detect pollution. To recognize wildfires early on, I'm building a highly sensitive flame sensor in this video. I decided to go with a Hamamatsu R2868 Phototube, which can detect a lighter flame from a distance of 8 meters. I also ordered the corresponding driver board, which contains the high voltage power supply for the phototube as well as the signal processing electronics. Here is a quick overview of the phototube and the PCB. And this is how it works. Flames and electrical sparks emit UV light with a wavelength of 185 to 260 nanometers. The sun also emits this range of UV light, but it is blocked by the Earth's atmosphere. When more than a certain amount of UV light enters the cathode through the UV transmitting glass, electrons are emitted from the cathode surface due to the photoelectric effect. The electrons are attracted to the anode side by the energy of the electric field and collide with the gas molecules in the tube as they accelerate, resulting in the ionization of the gas molecules. Electrons and positive ions are generated by the ionization. The number of electrons and positive ions increases at an accelerated rate as they repeatedly collide with other gas molecules. When the UVTRON specific discharge conditions are met, a large current flows repeatedly between the anode and cathode, producing a discharge state. The phototube comes with different cathode materials and therefore work functions. Okay, enough theory. Let's jump directly into the build. These are all the 3D printed parts needed for the flame sensor scanner. Since the sensor unit is designed to rotate continuously, a slip ring is required. If you have no idea how a slip ring works, the illustration I drew might help you. Since PLA always shrinks, all holes must be re-drilled to the appropriate size. Et voila, the mechanical assembly is complete. Before we hook this up to a microcontroller, we need to understand the signal processing circuit. Fortunately, it's pretty simple and basically consists of just a CMOS 4017, a decade counter with 10 decoded outputs. Depending on which jumper is set, the counter counts up to a certain number of pulses from the phototube before it generates an output signal. If we use output 1, we can connect it directly to a digital pin of the microcontroller and use the internal pull-up resistor. And this is what the flame scanner looks like once it's wired up. To limit the field of view, I resin printed a cover for the phototube. Okay, let's put it to the test. Since it was very windy, I used a butane torch for testing. It's amazing how sensitive the phototube is, even outdoors, without all the reflections from the walls. Even from 15 meters away, the sensor reliably detects the butane flame, even through bushes or tall vegetation. By the way, our friend's YouTube channel Project 326 has also created a great video on this topic, link in the description. Unfortunately, that is all the time I have for you today. Thanks for watching. Stay true, stay you.